Okay, students. So now we are going to observe the different types of pure substances. So you all know how to classify pure substances and non-pure substances. So what I have here are all pure substances. So again, how do we classify pure substances? As elements and compounds. So as examples for elements and compounds, I have all these substances. You can see here, this is copper. And you can see with the name, I have also mentioned the symbol, chemical symbol, because we are discussing that with the lesson as well. So here you can see copper. This is the copper metal. You can see the nature of the copper metal, reddish brown color, the shiny nature as well as the metal pieces. So you can observe that. Then here we have iron. Iron is present in the form of black color powder here. Normally you all know the iron objects which are made up of iron. They are solids. Here it is the iron powder that is shown to you and the symbol is Fe. Then here I have another element that is sulfur. The symbol is S. And here you can see that again is a crystalline solid substance, yellowish color crystalline solid substance. And here students, can you all see this one? This is mercury. So here students, you can see this again is an element, mercury. The symbol is Ag and you can see it's a liquid metal. You have to remember it is an element, it is a metal and it's a liquid metal. So when I move the petri dish, you can see the movement of mercury. That is because it has a high density as well as it is a metal, it has certain special properties. So that is mercury, again an element. Then we have here, this is carbon. Carbon, you are familiar with carbon. In lead of pencils, we have carbon graphite. So here also again it is a black color substance. There are different forms of carbon as well. So this is again an element. So then we have aluminium, Al. That is again a silvery shiny metal, an element. So that is aluminium. So all these, now these five, copper, iron, sulfur, carbon and aluminium, they are elements and they are all in the solid form. Here mercury is again an element, it is in the liquid form. Then I have here the chlorine gas. So now here students, can you all see the now I have taken two boiling tubes so that you can compare. This is an on my left side, it is an empty boiling tube and on my right side you can see that is the boiling tube that contains the chlorine gas. So you can identify it as the greenish yellow color gas. So normally students, we don't prepare this in a very large amount because it's somewhat harmful to the health of us. So because of that only a small amount has been prepared, but I am sure you can observe the color there. So that is also an element. So as you can see students, the pure substances, the elements, they can exist as either as solids, liquid or a gas. So those are the elements, one type of pure substances. Then I have another three substances here. They are also pure substances but they are compounds because they are made up of more than one elements. So here you can see copper sulfate. You can see the blue color crystalline nature, that again is a solid. So that is copper sulfate. Then we have sodium chloride, NaCl. So NaCl is the common salt, sodium chloride that is available in our household as well. Those are white color crystalline solid substances, sodium chloride. And here glucose is something that you are familiar with. That again is a white color solid substance. So that is also something you all know. So copper sulfate, CuSO4, sodium chloride, NaCl and glucose, the chemical formula is C6H12O6. So you will be introduced to all these atomic, the symbols as well as the chemical formula in this lesson. So that is why I have written down all the formula here. So from this, I am sure you all can understand that there are non-pure substances like the drinking water, sea water, all the different types of substances which are mixtures, and then we have the pure substances. Under pure substances, we have the elements and the compounds. Okay, students. So now we are going to observe the nature of homogeneous mixtures. To do that, I have salt here. So what I will do is I will transfer some salt. It has to be 2 grams, but since this is going to be a qualitative activity, I'm just taking a yogurt spoonful of salt, and to that we need to add some water and dissolve it well. So you all know that salt dissolves well in water. So now you can see, students, the salt is completely dissolved in water, and what we need to observe is how the solution looks like. You have to look at the composition, the clearness of the solution or the transparency of the solution, as well as the composition of the solution. So this is a colorless solution. You have to observe whether the transparency is uniform throughout, and after that we have to leave it aside for a few minutes, and then we have to observe that. Okay, students. So now can you all see the solution clearly? So you can see the transparency is uniform throughout the solution. It's a clear, transparent solution, and you have to understand the composition is uniform because its transparency is uniform throughout the mixture. So such mixtures are known as homogeneous mixtures. So now we are going to observe the second type of mixtures, heterogeneous mixtures. So you all know what we need to do. We need to take a small amount of clay, which I have here. So because I used 2 yogurt spoonful of salt in the previous activity, here also I'll be using 2 yogurt spoonful of clay. So we have to take that into the beaker, add water. Again, you all know, students, this is a qualitative one. We are just going to observe. So I will mix it completely. But you know from experience, the clay does not dissolve completely in water, but you can see there is a difference in the color of the solution. Now water is transparent, clear, but here you can see the clay mixture is slightly brown in color. And also, if you observe it throughout, you can see a difference. And before we come to a conclusion, we have to let it to stand for some time, say about 2 to 5 minutes would be enough. Okay, students. So now can you all observe the nature of the clay water mixture? Can you all see the difference in color? At the top, it's more lighter brown in color, whereas towards the middle of the solution, the color gets darker, and at the bottom you all can see it's more darker, and also you all can observe the solid components here. Towards the bottom there are solid components deposited at the bottom. So that is completely different from the first solution, that's the salt solution. This is a homogeneous mixture where the composition and the properties are uniform throughout the mixture. But the second one, that is the clay dissolved in water, is a heterogeneous mixture. Why? The composition is not uniform throughout the mixture, and also you can see the physical properties such as transparency, color, all those are different throughout the mixture. So now I am sure you all can understand the difference between homogeneous mixture and a heterogeneous mixture. So